Whether it's biker gangs or bachelorette parties, a lot of people love to get tattoos. Nearly a third of people in the US and a quarter of people in the UK have at least one tattoo. That's a lot of people. And getting that sweet body art involves injecting foreign material into the body, not to mention the teeny puncture wounds from tiny needles as the ink is injected. This process can cause inflammation, and inflammation means the immune system is getting involved. But even after the tattoo-induced inflammation subsides, it looks like that sick dragon on your back is still affecting your immune cells, which could teach us something about, of all things, vaccination. To know why your immune system is on the alert when you get a tattoo, we have to talk a little bit about what tattoos are. The inks are insoluble pigments suspended in alcohol or water. Those pigments can be natural or synthetic chemicals. Sometimes metal oxides are present. Some of the components in tattoo ink have been known to cause allergic contact dermatitis. In poorly regulated inks, there can be high levels of certain metals or additives that aren't great for you. Also, tattoos are made of many tiny injection sites, and these can get infected if not looked after properly. But let's go with the best case scenario. High-quality tattoo ink injected under sterile conditions. When you get a tattoo, ink is micro-injected into your dermis, the middle layer of your skin, below the sheddable skin cells of the epidermis. Some of that ink gets washed away to the nearest lymph node, but most of the pigment sticks around. Your body's foreign object alert goes off, recruiting immune cells called dermal macrophages to check it out. This is your immune system's job. There's no way to say, "Don't worry, boys, I'm doing this on purpose so you can hang back for now." Besides, given the risks we mentioned earlier, it's probably good for your immune cells to get involved just in case. The skin gets inflamed because immune system signaling can cause swelling and redness as blood vessels dilate and immune cells arrive on the scene. But ideally, when those macrophages show up, tattoo ink is the only foreign object around. These cells swallow the pigment but don't digest it. They stick around, keeping the ink in place. A macrophage doesn't live forever, but when it dies, another macrophage comes along and re-swallows the ink, so the tattoo stays put. Unfortunately, tattoo ink isn't a healthy diet. These macrophages have shorter lifespans than those that don't eat ink. So, maintaining a tattoo involves cycling through dermal macrophages. But how does that affect the immune system overall? To test this, in a 2025 study, researchers tattooed mouse foot pads with red, black, or green ink. As we've mentioned, tattoo inks are not equal. Setting aside the lack of standardization in additives, different colors have different pigments, hence the team testing 3 different inks. What they found was that pigment accumulated in nearby lymph nodes, causing a color-dependent increase in node size, which was still significantly different 2 months post-tattoo. There was also an uptick in the production of immune signaling molecules immediately post-tattoo, as well as recruitment of various types of immune cells to the dilated lymph node. Basically, the immune system was being vigilant. The immune signals varied in timing and intensity between dye colors, but all had some long-term effects. All this got the researchers interested in how tattooing would affect the immune system's responsiveness to vaccination. Vaccines work by giving your body a piece of an infectious agent in advance of infection, or a dead version or a genetic recipe, depending on what kind you're talking about. In general, though, think of it like showing your immune cells a mugshot so they can do a drill of their response. This way, the body can get itself primed and ready to fight the real invader. Vaccines are often delivered by injection, and while we already know that it's a bad idea to inject a vaccine into a fresh tattoo or to get a tattoo at the injection site just after vaccination, it wasn't clear how vaccines and tattoos interact more generally. And if you didn't know that, yeah, wait at least a month between getting a vaccination and getting a new shoulder piece. We'll come back to that new study, but before that, all science needs funding, so here's a quick break. This SciShow video is supported by Brilliant, the online learning platform offering a new way to learn math and science and programming and data and a range of topics. We all know the old strategy of cramming a bunch of formulas into your head for a quiz coming up way too soon doesn't lead to lifelong knowledge. So Brilliant lets you play around with concepts until they make sense. Like in their course on the coordinate plane that shows you how to plot points and visualize the mathematical world. To learn for free with Brilliant for a full 30 days, go to brilliant.com cia.org/scishow, scan the QR code on screen, or click on the link in the description. They're also giving you unlimited daily access to everything on Brilliant with 20% off an annual premium subscription. So in this 2025 study, mice were given a COVID-19 mRNA vaccine 2 days or 2 months after tattooing, and there was an effect. Tattooed mice had lower spike presentation on macrophages. mRNA vaccines for COVID-19 deliver blueprints for a harmless piece of the virus. In order to work, immune cells like macrophages have to take up the mRNA and translate it into the virus's so-called spike protein. Then they bring it to some B cells and go, yeah, get a load of this. Then the B cells go, oh, so that's what it looks like. Cool, I've been warned and will be ready to make a bunch of antibodies for the next time it shows up. But in the mice with tattoos, the get a load of this part was happening less. Tattooed mice also had reduced production of the type of antibody known as IgG, and IgG is one of B cells' go-to weapons. Since their macrophages were already busy, they weren't expressing the spike protein as well. So they weren't presenting B cells with example spike protein, which basically means the vaccine didn't work as well in tattooed mice. And they found that human immune cells cultured in a dish that were given the mRNA vaccine behaved similarly to the mouse model in the presence of different tattoo inks. But it's not all bad news. A different set of mice were given a UV inactivated flu virus, a type of vaccine that doesn't require macrophages to take it up and make the antigens itself. In this case, the mice with tattoos had more robust responses to the vaccine than the control group, especially those tattooed in red or black. In a way, the tattoo ink had primed the immune system. We call ingredients that do this adjuvants, and they're often administered with vaccines to enhance their effects. So it looks like the heightened immune surveillance caused by tattoos could be a good or bad thing for vaccines, depending on the type. Also, the effects varied depending on how recent the vaccine was. But that's not where the how has tattooing affected vaccination story ends. A 2008 study showed that injecting vaccines using a tattoo gun was more effective than your typical intramuscular injection. Subsequent studies have shown similar results when it was a DNA-based vaccine being injected. So even if it turns out tattoos don't boost some vaccines in humans the way they do in mice, one day your immune system may still benefit from tattoo technology, in theory anyway. Obviously, vaccination wasn't ever the intended use of tattoo guns, so researchers have been tweaking the system to enhance vaccine delivery. Having tattoos could influence how your body responds to vaccination. The type of ink and the timing could make a difference, as could the type of vaccine. Or at least they do in mouse models, which are famously not people. More work needs to be done, especially human studies, to see what the pros and cons are. Obviously, there's nowhere near enough evidence to make a recommendation about tattoos here. But what does seem clear is that tattoos are in a long-term relationship with your immune cells, so it makes sense they'd affect immune responses. Might not be something you think about when you're in the artist chair, but it goes to show just how complicated our bodies are.